Ahoy there, mateys. I'm Mr. French. I'll be your virtual instructor for this lesson. This is Algebra 1, Lesson 9.4. Solving quadratic equations by completing the square. All right, let's get some learning. So, 9.4. 9.4. Solving quadratic equations. Solving quadratic equations by completing the square. So last chapter, chapter 8, we were solving some quadratic equations, and the main method that we used was factoring, right? So that would be like, so it's like recall factoring. Factor, I want that to be an R, factoring. So that would be like solve. Let's say we have x squared, I'll go with, now let's go with plus 5x plus 6 equals 0. We're like, ooh, we have equals 0, cool, I like that. Now let's see if I can factor this left-hand side. So let's see, I have a 1x squared. So because of that, I can look for two numbers that multiply to be 6 and add to be 5. And you might come off to the side and be like 6. Well, 6 is 2 times 3. 2 times 3 equals 6, and 2 plus 3 equals 5. Oh, cool. So I can factor this straight to x plus 2 times x plus 3 equals 0. So if this term times this term, if this factor times this factor equals 0, then this equation will be true for whatever value of x will make the first factor equal 0, because at that point you have 0 times x plus 3 equals 0, which 0 was what you'll get on the left-hand side. So we can say, all right, x plus 2 equals 0, or x plus 3 equals 0. Subtract 2 from both sides here, you get x equals negative 2. Here you get x equals negative 3. All right, cool. We found the two values of x that we can plug into our original equation and make it true. So factoring was great, but what if what you have is not something that can be factored? One tool that we can use to solve it then is completing the square. So completing the square partially is a tool for solving quadratic equations, but we'll also see, well, you'll see it probably a little bit in Algebra 2, definitely in pre-calculus if you want to take those classes, that completing the square is also an important tool for getting standard forms of equations for shapes like circles and ellipses and hyperbolas, in order for us to identify like what the size of the circle is, or how wide and tall the ellipse is, and where it is. Completing the square is something you have to do a bunch with those kinds of shapes and their graphs. So it serves more of a purpose than just solving quadratic equations, but it is a tool for solving quadratic equations. All right, completing the square. Basically what we'll do is we will take a quadratic expression and we will modify it in order to create a perfect square. So you might recall from last chapter we did a little bit with perfect squares. Perfect squares being if you have something like x plus 4 squared. Well, what is that but an x plus 4 times another x plus 4? Okay. Well, if you multiply this out, x times x is x squared, x times 4 is 4x, 4 times x is another 4x, and 4 times 4 is 16, which this simplifies to x squared plus 8x plus 16. And we saw a certain pattern here. The pattern that we saw is that this perfect square, an expansion of this, well, what do we have? We have the first term, x squared. We have this last term, 4 squared. And then we have these two terms multiplied by each other. X times 4 is 4x doubled. And so if we have squared, squared, and then double of the square root of this times the square root of this. So square root of this is x, square root of 16 is 4. X times 4 is 4x, doubled is 8x. But this pattern we can rewind to be factored like this. And what this lesson does is we start out with something that maybe doesn't fit this pattern, but we will modify it to fit the pattern so we can turn it into this, and then once it's turned into this, then we can solve. That's kind of the gist of what's going on. We'll step through it. So let me give you some step-by-step instructions, and then we will do an example. All right, so let's just say to solve no, I don't want that to be ax. I'm just going to say this. To solve x squared plus bx plus c equals 0 by completing the square. Here's what we want. 1, move c to the other side, leaving, let's see, 0 or this, it can be 0 on this side, or it can be any other number, 0, I'll say, or some other number. We don't really care. All we care, all right, is that we have this pattern going on. Move c to the other side, leaving the x squared plus bx on the left. All right, 2, add to both sides b over 2 squared. We want to add to both sides. There we go. Add to both sides, b over 2 squared. What we're doing is we're creating the right pattern to have a perfect square. Because if this middle term is square root of the first times square root of the second doubled, well, we undo the doubling by dividing by 2, and we undo the square rooting by squaring, and it creates this right c value to have a perfect square. Because maybe what we started with here is not right to be a perfect square, but if we add this to both sides, we will now have on the left-hand side the right pattern to have a perfect square. So this leaves you with x squared plus bx plus b over 2 squared equals, I'll just say like whatever, because we say that on the right-hand side, maybe we started with 0, maybe we started with something else, we don't know. And we moved the c over. So we had is some number minus c, and so we don't really care what that is, but whatever plus b over 2 squared. So whatever plus b over 2 is a different whatever number. We don't care about that as much, so that'll come up when we solve. Okay, so then what we do is we can say factor x squared plus bx plus b over 2 squared as x plus b over 2 squared. So this left-hand side is going to become that, because we created the right pattern here to factor this as one term squared, as what's one binomial squared. And maybe we'll look at one where this pattern, where you can see it work with the numbers, and then if you're ever in doubt, you can always take this, and because this squared, you can take these two terms times those two terms again and multiply it out, and it'll take you back to what you started with here. So what we have here is factor that. So now what we have, I'll say now we have x plus b over 2 squared equals, I'll say a different whatever. A different whatever. Whatever. All right, now to solve, because that's, oops, this is step number 4 now. We're wanting to solve this equation. We're wanting to find what values of x will make it true. I could say here square root both sides. So what that gives us, when we square root, this thing squared, we're just left with the x plus b over 2 on the left-hand side. And the right-hand side is plus or minus the square root of our different whatever. Plus or minus, because anytime you're dealing with, you started with a variable being squared, and then you're trying to get that variable. Well, let's see, I'll just try it. If you started with, let's just say x squared equals 9. What could you plug in for x to make this true? Well, we could plug in 3, because 3 squared is 9. But we also could plug in negative 3, because the negative 3 squared is also 9. So whenever we have a variable being squared and we're trying to find what that variable is, when we take the square root of both sides, we need to take plus or minus square root of 9. Well, what's that but plus or minus 3? In other words, they're saying a positive 3 is what x could have been, or a negative 3 is what x could have been. We need that plus or minus whenever we take the square root of both sides when we started with a variable squared. So here we have a variable being squared. We're taking the square root of both sides. We need to do the plus or minus. So then what do we get now? We could just say like finish. I could say subtract. Well, I'll just say isolate x. Isolate x. So what do we get? We would subtract b over 2 from both sides. So we get minus or a negative b over 2 plus or minus whatever this came out to be. Plus or minus this different whatever. Now what happens is depending on what's inside the square root, if what's inside the square root is like 9, and if b is like 8, we have like a negative 8 halves, well that's negative 4, plus or minus 3, because square root of 9 is 3, negative 4 plus or minus 3, you'll get 2 different integers as your answer. You get a nice answer. Sometimes though, we get ugly answers for this. And your homework has it so if you get a nice answer, great, write that nice answer. If you get an ugly answer, write the exact answer, so leaving whatever fractions or square roots cannot be simplified, and then also use your calculator to get a decimal rounded approximation of what your answer is. But we'll see that with an example. All right, so. Let's do an example here. I'm going to do an example of one of these whole solving so you can kind of see what the end goal is. And then we'll rewind and we'll look at how to do a couple of the earlier sections of the homework. Okay? All right. And I want to start out with one that comes out nice, and then we'll look at one that comes out kind of ugly. Okay? That'll be the plan. So let's go with this. Let's say solve. And let's solve. Where's one I want to go with? Not that one. Yeah, I'll go and go with this one. X squared minus 8x minus 1. X squared minus 8x minus 1 equals 8. Equals 8. All right. Now, one thing that I didn't point out yet is here, the instructions say to solve x squared. Notice there's no a here. There's no ax squared. In other words, it's assumed that we're starting with 1x squared. Okay? These instructions work for that. If you had a different number here, if you had like 2x squared or 3x squared or 1/2 x squared, what you have to do is you'd have to start out as a first step of dividing everything by that a value, dividing everything by that x squared coefficient. So that once you divide everything, if you had a 2x squared here, you would divide everything by 2. And at that point now, you have x squared plus some number x plus some number equals some other value. And you have what you need to follow these steps. So I don't think, yeah, you don't have, oh, you have one in the homework where you'll have to do that. We have to start out dividing. So number 13, in the homework, you'll need to start out dividing everything by 2. Now you have a 1x squared plus 8x plus 105, or equals 105. Now you have what you need to follow these steps. Okay, but here we are starting with the 1x squared. So step 1, move any number that is by itself to the right-hand side, leaving you with just the x squared plus bx on the left. So I'm going to start out, I'm going to add 1 to both sides. So that's going to give me x squared minus 8x equals 9. That was my step 1, if I kind of let you know that the steps that we're following. All right, I added 1 to both sides, so my negative 1 plus 1 left me with no constants on the left, and then 8 plus the 1 gave me 9. All right, nice. Now I'm going to add to both sides b over 2 squared. So what I'm going to add here, this is my step 2, I'm going to have x squared minus 8x, I saw this, plus negative 8 over 2 squared equals 9 plus negative 8 over 2 squared. Okay, this can be simplified a little bit. And yeah, so let's do that. But I don't want to do much simplifying to the left-hand side because what I'm moving to is I'm moving to this binomial squared. So I don't want to do I don't want to bother with rewriting x squared minus 8x plus whatever this simplifies to, because my goal is not to simplify here, my goal is to factor. But this right-hand side I will want to simplify. So I could, yeah, so I'm not going to bother. Let's just go with x squared minus 8x. Well, what is this? Negative 8 over 2. I'll at least do this amount of simplifying. Negative 8 over 2 is negative 4 squared, right? Negative 8 over 2 squared, same thing as negative 8 over 2 is negative 4. Negative 4 squared equals, oh, let's see, that's 9 plus a negative 4 squared. Negative 4 squared is 16, so what I'm dealing with here is x squared minus 8x plus a negative 4 squared equals 9 plus 16. You don't have to show all these steps. I'm just showing each little increment of what's going on here just to make sure that you're able to follow okay, especially because you're not live here, so there isn't the opportunity to be like, wait, Mr. French, can you explain how you went from that step to that step? Because it seems like you maybe did a couple things at once, and so I'm showing everything here. All right, so this is actually x squared minus 8x plus a negative 4 squared. 9 plus 16 is what, 25? Ooh, I like that. I like seeing perfect squares show up. 5 squared is 25. Okay, so now I can do my step 3. I mean, I could have done it earlier, but I'm just slowing down and taking little steps at a time. Now I can go from this 3 terms down to this 2 terms squared. So in step 3, I take my x squared plus whatever x plus this thing squared, and I rewrite it as x plus the b over 2 squared. So my left-hand side becomes x. Now it would be plus, what was this b over 2? Negative 8 over 2 was my negative 4. So my b over 2 here is negative 4. So rather than writing plus negative 4, I'm just going to write this as x minus 4 squared. Right? That minus 4 is really a plus negative 8 over 2, or plus negative 4, okay, squared. So I went from 3 terms down to these 2 terms, this binomial squared on the left, and I still have my equals 25. Okay, step 4, square root both sides. Step 4, square root both sides. Okay, well that gives me x minus 4 equals plus or minus the square root of 25. Cool. Now I just need to finish solving. I say isolate x, really it's isolate x and simplify. But so I'm almost out of space here, but I think it'll work here to do step 5. Well, what do we have? We have x minus 4 equals plus or minus, so what's the square root of 25 of 5? So I'm going to add 4 to both sides. So I get x equals 4 plus or minus 5, which is really 2 different things. I have x equals 4 plus 5, 4 plus 5, or I have x equals 4 minus 5. 4 plus 5 is 9, so I have x equals 9. That's one of the solutions. And then x equals negative 1. That's my other solution. And I could check by plugging 9 into the original equation, in which case we have 9 squared minus 8 times 9 minus 1. and we would get 8 as the answer. Or a -1. We could do -1 squared minus 8 times -1 minus 1, and we would once again get 8 as the answer, because these are the two values that solve that equation. All right? Hopefully that makes sense. That's one that comes out nice and pretty. We get integers as answers. Let's do one where we don't get integers as answers, and we can see what that can look like. Okay? All right, I'm going to erase. The nice thing about the videos, if you're ever behind on your notes or you want to like, wait, what did he say? I want to listen to that again. You can always back it up just a little bit or push pause to finish up some notes. So do that as needed for your notes. And here we go. Let's do another example. All right, erase this. So this time, I want to solve this x squared minus 2x minus 14. X squared minus 2x minus 14 equals 0. All right, step 1. Well, so first of all, do I have a 1x squared? Yes. Okay, cool. I can proceed. If you have a 2x squared or a 3, let's say we have a 5x squared. We need to start out dividing everything by 5 to then proceed from there. Here, though, we do have a 1x squared, so I can start out. I'm going to throw the -14 to the other side. That's going to give me x squared minus 2x equals a positive 14, because I added 14 to both sides. That's step 1. Nice. Step 2, add to both sides, b over 2 squared. So that was step 1. Okay. Step 2, we're going to get x squared minus 2x plus, what's b, -2, so -2 over 2 squared equals 14 plus -2 over 2 squared. Okay, I'm going to go a little bit more quickly here. On this left-hand side, I'm going to jump straight to the factored version of it, because I get x, and then just what's inside the parentheses here? What's inside the parentheses here? -1. I'm going to go x minus 1 squared equals, I'm actually doing step 3 here. So this is a -2 over 2 is -1. When I square -1, I get 1, so it's really 14 plus 1, that's 15. So I have x minus 1 squared equals 15. This, if you want to be more abbreviated with your work, as if you don't want to be quite as thorough with your work, what I'm showing here is probably the minimum, yeah, it is the minimum amount of work that I'd like to see. We went from our original equation to then throwing all the numbers to the right-hand side, to then adding our b over 2 squared to both sides, to then jumping straight to the factor. X, let's see, what's -2 over 2? -1. X minus 1 squared equals the simplified version of this. Step 4, what are we going to do? Take the square root of both sides. So that's going to give me x minus 1 equals plus or minus the square root of 15. Square root of 15. 15 is not a perfect square. So what we're dealing with is square root of 15 does not simplify any further, at least not in its exact form. If you take your calculator and you do the square root of 15, it'll give you, what, 3 point something, and the decimals just keep going. I mean, your calculator, they eventually stop. But the square root of 15, the decimals keep going forever. So there's no other way to write the square root of 15 and be exact. In other words, any other way of writing the square root of 15, we're having to round in some shape or form. So because of that, we're just going to end up leaving this as the square root of 15 for our exact answer. So what I mean by that is step 5, we need to finish solving for x. I'm going to add 1 to both sides. What do you have? X equals 1 plus or minus the square root of 15. That is my exact answer. Exact answer. Hi, I'm recording lecture video. But yeah, things are going great. Thanks. That is my exact answer. Now let's look at how to do the rounded answers. That's exact. The rounded answers is literally just take your calculator. I like to do the minus first just because that gives me the smaller answer. and then the plus second because that gives me the bigger answer. I just like to list the smaller answer and then the bigger answer. So we have x equals, we have 1 minus the square root of 15. So if I take my calculator, do 1 minus square root 15, I get negative 2.87. That's one of the answers rounded. What do the instructions say here? Round to the nearest tenth. That's what your homework has. So I'm going to round this to 2.9, approximately negative 2.9. Really, even I should, I don't know if you use this kind of squiggly equal sign. It means that it's not exactly negative 2.9, it's approximately negative 2.9. This kind of equal sign is used to express that idea. That this isn't an exact answer we're rounding, we're approximating. This is close to what we started with, but it's not exactly the same thing because we did some rounding here. And here we have x equals 1 plus square root of 15. So we get x is approximately, so I do 1 plus square root of 15, and we get 4.9. X is approximately 4.9. So these are my rounded answers. Okay? So that's what it'll look like if you don't get a nice answer like the first example and you get something kind of ugly like this. You'll give the exact answer and then you'll give the two different rounded answers. And the exact answer you can leave as one expression here like this with a plus or minus. Okay? Yeah, hopefully that makes sense. That would be another example of solving. Now there are two other kind of problems in the homework that we can look at. I'm going to erase this and let's look at it. The first section of the homework is find the value of C that makes each trinomial a perfect square. Find the value of C. Find the value of C that makes each trinomial a perfect square. And what we have, I'll grab just a miscellaneous example like, let me go with, no, not that one, maybe that one. Sure, I'll go with that one. X squared minus 24x. Yeah, sure. Minus 24x plus c. So we want to find what number is it here that would create a perfect square for us. Well, guess what? It's this thing that we've already been dealing with. It's just that b over 2 squared. So my answer here, so how to do these, it's our b over 2 squared. That's what we want to create a perfect square. So I'm going to take negative 24 over 2 and square it. What's that? Negative 24 over 2 is negative 12 squared. And what's negative 12 squared but 144? That's my answer. So for all of these, you can just take that b value divided by 2, square it, and that's the number that if the number is here, you have the right pattern to have a perfect square. So that's the first section of the homework. Sometimes it might come out as a fraction. Like if I grab one that's a fraction, it might be something like this. You might have something like x squared minus 15x. No, I'll go with plus 7x plus c. I'll go with that. Okay, what does c need to be here for in order for it to be a perfect square? 7b over 2 squared. So I have 7 over 2 squared. 7 over 2 doesn't simplify. So if we have a fraction that doesn't simplify, that's 7. If we have a fraction that doesn't simplify, we can just square the top and square the bottom. If I square the top, I get 49. If I square the bottom, I get 4, 49/4. That would be my answer. All right, so that's that kind of problem. And then the second section of the homework is like what the first couple examples I did, which is solving the equation. The third section of the homework, let me erase this. The third section of the homework has instructions like this. Find all values of C that will make each trinomial a perfect square. Find all values of C that will make each trinomial a perfect square. Each trinomial a perfect square. And I just wrote these the way the textbook had them. In hindsight, I wish that I would have changed this to using B instead of C, because I feel like it's kind of confusing potentially to use a C here when it's in the B spot. So I'm going to say, let's pretend that it's written actually as find all values of B that will make each trinomial a perfect square. Because what that will look like is something like, example, x squared, let's go with plus bx plus 81. All right, let's see what we have there. Well, we know that what goes here is a b over 2 squared, right? That's that. So we already have the b over 2 squared is, this is C, this is C, this is C, and that's the same thing as b over 2 squared. Okay, well, let's turn this into an equation to find what b value we want if we know what C is and we don't know what B is. So we would take the square root of both sides, right? Now B is our unknown here. B is our unknown, so I'm taking the square root of both sides. So I got to say plus or minus the square root of C equals B over 2. I'm going to solve for B, so I need to multiply both sides by 2. So I get plus or minus 2 square root of C is what B is. So this is like my little formula, or if I know C and I want to know what B here is, or should be, to make this a perfect square, here's a little formula I can use. So I know that C is 81. So I'm going to say here that B is plus or minus 2 square root of 81. All right, well, what's that? Plus or minus 2, what's the square root of 81 but 9? 2 times 9. So 2 times 9 is 18, so I can have a positive or a negative 18. That's what B should be. So if I had x squared plus 18x plus 81, or x squared minus 18x plus 81, that would be a perfect square pattern. So if we had x squared, let's say plus 18x plus 81, what would this factor to but x half of this, b over 2. So half of 18 is 9, x plus 9 squared. And if we had x squared minus 18x plus 81, this also factors to a perfect square, but it's x half of this minus 9 squared. So both of these patterns are perfect squares that can be factored like that. Okay? Then you have 4 review problems from 2 different lessons. And yeah, so hopefully that gets you well set up. As always, let me know if you have any questions, and I hope it goes well. Thanks.